Good morning, students. Today I am discussing about applied geotechnical engineering 18 series 6-2 for 6th semester students, module 3 and lecture class 7. So, friction circle method of determining the stability of slopes. So, friction circle method. In this friction circle method, the slip surface is assumed to be cylindrical, that is it is arc of a circle in section. The sliding mass is assumed to be acted by three forces, keeping it in the equilibrium as shown in the figure. So, let A, B, D, that is this is A, this is B and this is D, will be the sliding soil mass. O is the center, OA is the radius, distance at which that is the sliding soil mass is acting. And so O as a center, A into R into sin phi is the radial length at which the friction circle is acting. So now we have to construct this one. How to construct it? First, draw a horizontal line on a graph sheet. Mark at one point as A. A slope of an embankment is given. Mark the slope of the embankment, one vertical to n horizontal. Draw the inclined line. From A, measure the height of the embankment to a suitable scale and draw the horizontal line. Wherever inclined line, horizontal line intersect, that point will be your B. From B, draw the horizontal line up to D if it is given. If not, O as a center, OA as a radius, draw a slip circle which cuts that point D on the top of the embankment. Thus, the embankment with slip circle failure envelope has been marked. Next, step 2, O as a center, Ka gamma sin phi as a radius, draw a friction circle. After drawing the friction circle, so next step is we have to calculate the W. So W, which is acting at a distance of x bar from O. So how to calculate W? In order to calculate sliding soil mass W, A, B, D, A, first we have to we should know how to calculate W value. W is calculated by multiplying the density of the sliding soil mass with weight of the sliding soil mass. How to calculate weight? So weight, density is weight by volume. So weight is equal to density multiplied by volume. How to calculate volume? Volume is calculated by considering area of sliding soil mass ABDA multiplied by 1 meter length, because usually perpendicular length of the board or 1 meter length, all designs will be done. Therefore, so W is equal to the weight of soil mass, W is equal to density multiplied by volume. To find the volume, we should know the area of the sliding soil mass AB, curvilinear length DA. To get that area ABDA, following procedure is adopted. Let us consider a triangle area OAD. So triangle ABDA is equal to triangle OAD, curvilinear triangle, minus triangle OA, straight line triangle D. That means if I deduct this much area, we will get only this dotted line and this curvilinear portion, but sliding soil mass is composed of this portion also. Therefore, plus triangle ABD. Okay. So now, to get the triangle OAD, curvilinear triangle, half into base. Base is curvilinear length L, curvilinear into height is R, minus straight line triangle you are deducting means half into base AD, long chord line, into O AD by 2, mid-ordinate distance if I consider it as Y. So that will give half into base into height, plus half into base AD into BD. I will write a one line here, BD. That will give the area. That multiplied by 1 multiplied by density will give the weight of the sliding soil mass. From O, measure a horizontal distance, draw a vertical line, and that line will give W. Okay. Next, the resisting force Cm into L bar we have to write. Cm into L bar is at a distance of A. A is equal to R into L curvilinear divided by L straight line. L curvilinear is equal to pi r delta by 180. L straight line is equal to AD if you do it. As the curvilinear length is greater than straight line length, this A is greater than R. So draw a line perpendicular to AD. Wherever it intersects, draw a line Cm into L dash parallel to long chord AD. The intersection of W line and Cm into L dash line will use a point. If that has a center, draw a tangent to the friction circle in the upward direction. That will give the resultant. Next, we have to calculate factor of safety. Factor of safety is calculated by, you can see here, C divided by Cm. How to calculate C divided by Cm? So in order to calculate that one, we have to write the vector triangle. In the vector triangle, we have to arrange the three forces. As I said earlier, three forces. Number one, force W. Number two, force Cm into L dash. Number three, force R in tip to tail fashion. To write that one, you take a suitable scale. 1 centimeter is equal to x kilonewton. As W value is known, Cm into L dash and R is unknown. We are using vector diagram to calculate remaining two unknown values. So to a suitable scale, draw this line W. From the tip of W, draw a line parallel to Cm into L dash here, and from the tail of the line W, draw a line R which is parallel to this line, so that the intersection of Cm into L dash and R at one point, and the intersection of tail and tip of tail of the W and tip of the R will give the resultant force R. In this case, it is not necessary to calculate it, but take a scale, measure Cm into L dash, that will give x, that is kilonewton, or x value, that divided by L dash. If you do it, you will get Cm. Once you get Cm, though C is cohesion, in the examination they will give the cohesion divided by mobilized cohesion. If you substitute it, you will get factor of safety. So this is how we can calculate factor of safety by using this method. So now, problem on critical slip circle method. Determine the factor of safety against sliding for a slip circle shown in the figure. The properties of soil are C is 30 kN per meter square, phi is 15 degree, gamma is 21 kN per meter cube, embankment height is 12 meter, radius of the slip circle is 20.25 meter, center of gravity of the sliding wedge W distance from A is 11.4 meters, slip circle touches the top of the embankment at a distance 4 meter from B. So answer C, value is given, phi value is given, density is given. So to a suitable scale, take a scale 1 centimeter is equal to 2 meter or 3 meter, draw the embankment, go as a center, draw a slip circle, then Ka gamma Kr into sin phi, draw a slip circle, W value you calculate it, mark at a distance of 11.4 meter from origin, and A value, A is equal to R into L curvilinear by L straight line. You mark that A distance perpendicular to AD, wherever intersect, mark the R, and draw this one to a suitable scale. 1 centimeter is equal to 500 kilonewton. You will get W value. This line, draw this line parallel to this line, draw this line parallel to this line. Wherever intersect excess line, you remove it. You will get Cm into L dash 660 kilonewton. So once you get 660 kilonewton, so that divided by 24.4, L straight line will give 27.04 Newton per meter square. Factor of safety C divided by Cm, 30 divided by 27.04, 1.1 is just safe. but at any point of time we cannot possible to take this as a safer value. So it should be around 2.5 or 3 is there is safe, otherwise 1.1 is almost equal to 1 verge of failing. So this is how we can do factor of safety. Coming to the MCQ question, in a friction circle method, the slip surface is assumed to be cylindrical, that is the arc of a circle in section. That is true. In a friction circle method, the slip surface is assumed to be a circle, that is the arc of a circle in section. That is true. In the friction circle method, the sliding mass is assumed to be acted by a zero forces keeping in equilibrium false. In a friction circle method, the sliding mass is assumed to be acted by one force, that is false. It is acted by three forces. In the friction circle method, the sliding mass is assumed to be acted by two forces, so it is acted by three forces: W force, R force, U into L dash force. Therefore, the answer is false. In a friction circle method, the sliding mass is acted by three forces. The answer is A, true. In a friction circle method, the sliding mass is assumed to acted by four forces. It is false. In a friction circle assumed to acted by five forces. It is false. Circle method, the acted by six forces. It is false. In a friction circle method, the sliding soil mass at seven forces. It is false. These are the references we have taken for preparing this material. I take this opportunity to thank Department of Collegiate and Technical Education higher officers and students for giving me an opportunity to deliver this lecture, and I hereby inform all the students to go through the LMS content, and if you have any doubt you can feel free to discuss with us. Thank you.